I'm going to put in the chat right now a link to our Slack group, Slack community, however you want to call it. And so that if anyone is looking to get involved in the Slack community or ask more questions, look at more stuff that has to do with data on Kubernetes, you can see it here now in the chat. Let me just find the chat real fast and then I'll put it in there. There we go. Cool. So
I thought it was actually really cool. You had a whole channel just for, room just for the operators, because I cannot understate how much operators save your engineering time. And there's a slide where I kind of get into this a little bit, but and there's not that many operators around either yet, right? It's like a very new paradigm. I think people are starting to kind of get trusting operators more and more. But anyway, sorry, I thought it was really cool that there's a whole section.
For sure, operators are like the cutting edge, we could say, and
exactly,
that's something.
Yeah.
There's so many people that are asking like, which operator is best for my use case, and why are you using this operator instead of that one? And I think those are the questions that we want to be having more and more, and hopefully people that are helping or that have already used certain operators can help us in understanding what the pros and cons are of each one.
We should totally have a talk on just that. That'll be fun.
Actually, yeah, it's very funny you say that, because that was one of I thought about even trying to have a series around operators, because it's like in 1 hour you can cover a bit about operators, but I think you would be able to get much deeper if there was a whole series. So if anybody out there listening has success with different operators or is using different operators and wants to talk in a series about them, get in touch with me. I'm in the Slack. I just threw it in the chat, or you can message me direct on here. So I think we are pretty good to get going. We have a few people that are joining us. I'm going to stop sharing my screen, and now I will give a quick intro, and then we can go and get started with Ren. So for everybody, I have the quick announcements I already did. I think we're good. Everybody knows we got a Slack. You're all in there. You also know our grand scheme of taking over the world one operator at a time. So if you want to talk about operators, or if you think that operators would be a good thing to dive into more, let us know in the chat right now, or tell us what kind of operators you're using and what operators you would want us to talk about a bit more. So just so everybody has a bit of background on who we are, I'm Demetrius, and I'm joined today by Ren Lee. Ren is an SRE at Arista Networks. And so, Ren, I usually start by asking our guests, what is the way that you found yourself, or that's a really weird way of phrasing that question. How did you get into tech is the easy way of phrasing that question. How did you decide that you liked it, and what made you jump into this world?
Sure. Actually, I wasn't expecting that question. It's funny because I didn't start computer science education or anything like that until like halfway through college. Because I was a pre-med, and I mean, it was kind of serendipitous because I was actually forced to take, as part of my kind of the undergrad education, just a computer science class, and I actually just kind of fell in love with it. And I mean, it sounds really cliche, but it was a lot of fun. I literally started with binary math. It was really so bare bones, nothing complicated, just binary math. And then after that, we jumped entirely to building HTML pages or something. And there's this program called Alice, which is a drag and drop coding. You just drag code blocks together. You're not even actually writing using a language. And I just loved, it was so creative. At the end of the day, I think I mean, there's obviously, you know, tech is entirely very heavily embedded on, logic and, just being able to critically think about problems. And like, I think a lot of people are scared away kind of by that. And there's that obstacle of like, oh, needing to learn, programming language. You need to be able to learn programming languages. And in my honest opinion, and I'm sure there's a lot of people with other different opinions, but like, language is great, but you also need to know like how systems work if you really want to, know how your
Mm,
application is going to run effectively,
totally.
right? So there's like quite a bit of like that kind of learning curve, but at the end of the day, I still find it one of the most creative and such a powerful tool to kind of solve different problems we need. And like, if you know how to program, if you know how to work with different, frameworks and whatnot, you can pretty much like tackle whatever problem you want, right? Like, and that's the freedom that I think is just so rare in other industries. Or, I mean, that might be, I'm speaking from my own opinion. I think I just haven't seen that kind of freedom, being able to pick up a computer and just do whatever you want, build an app,
Mm.
try whatever you want to do. Like, I love that. So I mean, I took that one class, and honestly, I was still a pre med, and I was taking like extra course load, just like taking more and more computer science classes. I just eventually switched over. That was kind of it, and then I loved it ever since. I've
Wow.
never looked back.
What a great
Yeah,
story. That is so
yeah,
cool. So you just said, all right, pre-med, this actually is more creative and I'm enjoying it more. I'm going to hop on over.
yeah. Also, I
Nice.
have to say, as a pre-med, I'm like extremely clumsy as a person. So like lab work was not
Oh
going
no.
great for me. And then, with coding, you can sometimes save yourself, like you can always roll back code change,
Yep.
you can kind of fix your mistakes. And it's like an iterative learning process. So I think it just fits, the kind of person I am. And
Totally.
I do wish more people would be like, I mean, especially coming from a female engineer perspective, like just just dive in and don't be afraid. Just learn, pick up a language, try to build something, try to build a website, whatever. Like, do any little thing you can, and I'm sure you're gonna have fun with it.
Yeah.
Yeah,
And that's it's funny you say that, and I'm gonna let you get into what we came here to talk about.
sure, of
But
course.
I think it's super interesting how you say that, because what we were talking about before everybody jumped on was this whole idea of, oh yeah, in most of these blog tutorials or whatever tutorials that you get, it's very simple. And they make it seem
Right.
like, oh yeah, this is super easy. You just plug this in and then run this command and you're good. You're up and running. And what we were saying is just how you don't normally get to hear this other side, which is like, dude, I tried this 5 times. It's still not working. Why is it not working? What is going on?
Right.
So the satisfaction that you get when it does work, I think that
Right.
endorphin high is there's a lot to say for that. Now,
Definitely.
let's go ahead and jump into what we came here for. And I think when you showed me the title of what you wanted to talk about, I I literally laughed just randomly, because I think we all can relate to this, we were running what? And it cost us
Yeah.
how much? And so
Yeah.
I'd love to just go into this a little bit more. I'll let you take it away from here. And I imagine you break down like what the stack is that you're working with at Arista Networks and how that's going. And I didn't ask you beforehand, but maybe you can share these slides with us for afterwards.
Oh yeah. I can totally can. Yeah. So I know our community is like very much around storage, but I do want to kind of cover a lot of just Kubernetes also as a whole, because it's like you can't just talk about storage. There's a whole lot of other things involved too, right? But like as an SRE, like what I care a lot about is making sure we can predict and have enough capacity on the cluster itself to run whatever we want to run on it, right? Our entire stack needs to be able to run on it as a step one. And step two, it needs to be able to scale, and our cluster needs to be able to support that, right? So like when you're kind of thinking of that aspect, it's a very holistic view of like what are all the different like buckets of problems you need to deal with. And I also want to kind of get into because I have experience running Kubernetes clusters both on-prem, on like in our own data centers, on our own machines, as well as currently I'm working more on the cloud, but so kind of like getting that different perspective as well. So anyway, let's get to it. Yeah, the title is literally one of the things we said during one of our meetings where we're going over like, oh, what was that monthly cost? Oh my God, are you serious? We spent like, some X crazy amount of dollars, and we're just like, oh, okay, well, I mean, I guess we should have seen that coming, but yeah, we'll get into that. So anyway, oh, sorry. There we go. Okay, so just a little bit about me before I start and kind of like what I work with. Yeah, so like I said, I used to be on a team that ran the Kubernetes clusters on-prem. So we had full control over our entire data center, over all the servers we ran, like our rack configurations, where our switches are, the topology, everything. So I mean, it's kind of fun to see that comparison between like running a Kubernetes in that environment, and then you go to an environment like on the public cloud where it's like you don't really have control over that anymore. But it's a very different setting. So I used to I managed our Garrett operations. We were like scaling, we were like converting from Perforce to Garrett, so like Git world of things. We were like expanding our Garrett servers everywhere, and making sure we have backups, HA, and all that stuff. We had a huge cluster on Jenkins, and I was actually the team lead for making sure we had enough Jenkins cluster availability so we can actually run all the builds we want. And like, not every team tells me before they start running a new build, whatever, new jobs and projects. So being able to kind of predict that. And that was actually how I really got into Kubernetes, because we were transitioning from running Jenkins agents on like just bare metals and like just using like single node servers separately. And we were like, okay, well, this is nice, but we're wasting a lot of resources on each of these servers, because the scheduling part isn't just like, if you have a Jenkins node and you just have like, let's say like 20 servers where you spread around builds, you don't really get that kind of like Kubernetes schedulers efficiency of scheduling different pods to actually run the different builds on it. I mean, you can do it, but it's just not as efficient as through like managing these nodes through a Kubernetes system, letting Kubernetes schedule pods and letting those pods do all the work of doing the builds. So that's kind of actually, I did the transition from the bare metal to running Jenkins on the Kubernetes, and we actually scaled up very quickly and massively on there. Like we had like almost like 500 times more builds through, because of the Kubernetes scheduler was so effective at like shoving all the different pods into different nodes. I have to mention OpenEDS a little bit here, because this is especially on-prem, and we had a lot of like different like kind of clunky monolithic services. We were like, trying to convert to this, everybody goes through this conversion of monolithic to microservices thing, right? And not every application we were running, especially like the custom ones we were building, had like, ready-made replication or high availability built in. So we were like, okay, well, but like if we want data redundancy, what's the quickest way to solve it? And then like OpenEDS is great because it's just like, you have a storage class, it's super simple. Everybody can just use the storage class and bam, you got 3 copies or 5 copies or whatever. Actually that was, and we still use it, and it's been like such a time saver for like, especially applications that just need data redundancy spread across multiple nodes. And it actually did also save us from like single node failures, right? Like you just, because your data is spread across multiple nodes, you don't have to worry about like one node dying in your cluster and then now you just lost all your data. So yeah, so that's kind of like what I used to work on. And nowadays I wrangle a lot of different services in our stack. So some of them are like Elasticsearch, Hadoop, HBase, Kafka, Zookeeper, you name it, the entire zoo. And I put Prometheus and Grafana just because I would not be able to do my job without these 2 services. Yeah, like effective monitoring honestly should be another talk, because like that is so important to getting operations correctly and having like everything running. Yeah, and then all this on Kubernetes, and it's like number 1 step, make Kubernetes work, making sure our Kubernetes cluster's healthy. Then you think about the applications at top, and it's it's a very, I think there's a bit of a interesting kind of aspect where people move to, running their applications on Kubernetes, and they're thinking like, oh, it's like simple. oh, like Kubernetes kind of like abstracted away a lot of these like traditional operations problems we used to think about, like per node problems or per server problems. And then like it's kind of funny because you once you start really managing the Kubernetes clusters, like you still have kind of the same problems, the same kind of resource problems that you think about, and actually that's kind of where I want to get in. But anyway, keep on swimming is literally my motto every day, making sure everything is working. So yeah, that's what I do. Um, so yeah, kind of this talk, I want to talk about, running Kubernetes, some of the war stories around there, but really kind of dive into resources, resource management through Kubernetes. I kind of touched very briefly on capacity planning, and also like what is the cost of running a Kubernetes cluster, and like how to think about it with different types of resources, and like what are there's some more stories that I want to talk about where like we just like had costs just kind of run out of our hands even without us noticing, and like hopefully other people can also get some takeaways from that and maybe not run into the same mistakes we did.
And you told us you can't give any specific numbers, but you can say a lot or a little,
Yeah,
right?
I'm gonna be as detailed into the problems you ran into as much as possible. I just can't talk about like actual dollar values or anything like that. Yeah, unfortunately.
So we'll
Um,
just say it was a big number or it was a small number or whatever.
yeah. Okay, great. Um, so I kind of touched on this a little bit about how we moved to Kubernetes and we kind of think the traditional kind of ops problems, we think they're kind of like gone, they're abstracted away. And I think that's true to some extent because Kubernetes does abstract away all of that from the developers very well. But like when you're actually running the Kubernetes cluster, you still have to think about the same things. And in this graph, I'm saying like the challenge is so much greater as you go to the bucket of problems with storage, because like CPU and memory, I mean, as a cluster as a whole, when you're looking at a whole cluster, you still have to think about like what is my total capacity of CPU available and memory available. The only reason why I think these are not as big of a problem as like let's say network or like the biggest problem, which is storage, is because CPU and memory you can always, I think, these are the types of resources that you can always optimize in your application. So let's say your application, like you're running like some simple Nginx server and some developer made a mistake and like requested 4 cores or something in their YAML file. Like, well, that's clearly wrong. We can fix that, and that server probably didn't even need like 4 cores worth of core time. And you fix that, or maybe the application can be split up into smaller services where it doesn't like monolithically need like some X amount of cores. Memory is I think even simpler, just because like you got memory leak somewhere if you're using way too much memory all of a sudden, or maybe you're not caching things correctly. But like CPU and memory are like tweakable things, even when you're deploying things on Kubernetes. So I consider that whenever I'm working with like kind of like we're running out of resources on a cluster, or some deployments behaving badly, like CPU memory, okay, they're like not that complicated a problem. Network I think is interesting just because this is where I think you start hitting into like really like constrained problems, especially resource constrained problems, just because let's say if you're running your cluster on-prem on like bare metal servers, like unless you start changing up your entire rack layout, like you're not gonna get that much more bandwidth and throughput. Like, are you really gonna go and change all your network cards on your servers to get higher throughput? I mean, maybe if you have the time and resources to do that, right? Or like your top of rack switches, are you going to replace all that? That's a huge cost. Actually, switches are not cheap. I would know because I work at a switching company. To get and you might have some bad services that just maybe sending way too much traffic across the line. Like but to get
Totally.
more capacity for a network all of a sudden is a big change infrastructure wise. And I mean, I talked about on-prem, but even on the cloud, I work mostly with actually Google Cloud GKE. So like if in that example, like you are still tied to a certain amount of network bandwidth, and that's kind of like, I mean, if you think about it realistically, that will always be the case because underneath the hood, you're still bound to like, actual servers, and physical networks. So getting like all of a sudden more network is kind of hard, but it's still tweakable. So I consider that like kind of the middle bucket worth of problems when I'm thinking about resources. I think storage like is a whole different world, a class of problems, because there's so many different layers to think about, and I'll get into that a little bit. What are the different, at least the layers that I think about when I think about storage? But I think it's also interesting in the fact that storage is one of those things that might just continue to always grow. Your need for it, your applications might just always need more storage, right? Like, I mean, I've never ran into a case where it's not common for an application to start saying, oh, I need like half the storage. Used to need like, 100 terabytes. I need like 1 terabyte now. Like that's not common, right? Yeah. So, and also what if you have to think about like backups, like redundancies, like how many replicas are you running? Like all that kind of, you're always expanding. It is one of the most cost fluctuating aspects. If you're looking at a whole cost of your Kubernetes cluster, like it is literally the most fastest growing and most fluctuating costs, just because of different deployments need different things, and then different designs, and I'll kind of get into that a little bit more. But I also think the storage, like thinking about storage as it is one of the most complicated, most challenging resource type to manage, just because of all the different layers you think about. And like, for example, at the base layer, and you're not even like thinking about Kubernetes at this point or application at this point. Like, let's just say you're just thinking about how to tackle like storage problems at like this hardware layer. And this actually applies to both cloud environments as well as on-prem. And in terms of like, I've experienced problems like this in both environments. So like, you might be dealing with, you care a lot about like, what's your read-write speed, right? Like that's like, if you're baseline, like let's say if you're writing to persistent volume, and let's say you're on-prem, like you're bound by the disk speed, like how fast you can write, the read-write speed. And also it's kind of funny because you're still constrained by the same physical properties, even on the cloud, because depending on what kind of storage you buy, kind of depending on what kind of type of different types of storage types. So for example, like Google Cloud has like multiple different like I would say like QoS classes almost for storage, the disks that you can buy, and like even there they all have restraints on like your peak read-write ops. Like, so like you need to think about that. Like, and you're not even thinking about applications at that point, but you're just trying to like figure out, okay, is my like base layer actually being able to write as much as possible? And then like, it's kind of funny because on the cloud, you also kind of, because depending on the vendor, you might also run into things like your, writes are being throttled weirdly because, your vendors like throttling in different ways. And a lot of vendors will do this, especially to kind of smooth out peaks in writes and reads as well. So like you might be wondering like, oh wait, I was supposed to get this much IOPS out of my QoS class disk that I just bought from you, but like I'm not hitting that. Oh, I'm being throttled. Okay, I didn't know that. I didn't even know that was a possibility. And it's actually funny because this is one of the things I have to deal with. And then like, so there's like that kind of challenges hardware wise, and then like if you're running things on prem, you might run into just even dumb things like, oh, my disks are dead, or like I have slow disks, or like all these kind of like hardware problems, right? And then you might want to think about your block size, or like access and location, like where is your data, right? And this actually applies to both on-prem as well as cloud. Like, if your application is running out of like East Coast, so let's say, in my case, we have data center both on both sides of the United States. And if you're running Kubernetes clusters on both centers, you sometimes do end up with a situation, well, we did, and then we fixed this actually, where like, oh, an application we schedule somewhere on like the East Coast, and then the data happened to be just like all the way on the West Coast. Like, that's bad, because you're rewrite, because it's gonna take, the latency is crazy, that you cannot live with that situation, right? So
how did you recognize that was happening, and how did you fix it?
Actually, I didn't know about it, but the developer that was writing, this is on our internal data centers. So this is before we like moved everything to cloud. Cloud has, obviously you wouldn't run into this because you have very specific regions where you run things out of, and then you can specify also like where your volumes are scheduled in terms of regions. And no, we just had metrics. Like the read-write speed was really, really slow. The application developers are like, hey, like I don't think it's our algorithms. Like this doesn't show up on any of our tests. Like what's going on? And then we finally realized, oh, like, well, it's a network-mounted volume, right? And it's like the volume itself is actually running out of like some node on like West Coast and your application on the East Coast. So it was pretty easy to find, but we didn't quite catch it. So we, as in like the SRE team, didn't quite catch it. The application team was like, hey, we're not getting the performance throughput that we needed. And after that, how we fixed it was just node pools, honestly. The node pools, we didn't quite have the node pools set up correctly for different data centers. And node pools, we just had like, okay, if you're trying to deploy things to, let's say, the East Coast data center, use this node pool, this storage class that is configured for all the servers that's running out of that data center, so you have a local server access, right? Rather than like jumping across the states to do this thing. So, and in that aspect, that is definitely done for you already on the cloud because, like I said, you are definitely running servers already out of specific regions, as well as like node pools are already like something that you configure straight up when you start the cluster. So it's kind of like a novice mistake to make, but like when we were just starting out trying to expand our Kubernetes clusters and like how to set it up correctly, so we were like, oh, lesson learned. I guess definitely, don't run into the situation.
Yeah, it goes back to what we were talking about.
Sorry, go ahead.
It just goes back to what we were talking about at the beginning, this.
Yeah.
It seems so easy, and then you learn through doing.
Yeah, I guess in that aspect, it's really, really, really important to just get your monitoring in place, because we would have never, honestly, like we would have not caught it. We would not have noticed it unless the application team actually had really, really good metrics set up, and that goes back to Prometheus and Grafana and everything again.
Yeah.
So I guess I kind of touched on that already, but like network mounted volumes, especially when you don't have that pairing of where your application runs and you're not writing to a host path mounted volume, that kind of like distance between where the application is running, where the actual volume is stored, and what's your throughput between these servers, that definitely matters. So that's like, it's kind of interesting because like there's already so much to think about at the hardware level, and we haven't even touched like Kubernetes or like the application itself. So and then I put next layer as Kubernetes is like level 9,000, because honestly the jump from I think hardware to Kubernetes problems is still a pretty big gap. So I think when it comes to like Kubernetes layer, now you have like extra added challenges where like and this is kind of where it gets interesting as an SRE, because I'm always trying to teach developers how to do things the right way, or at least achieve what they want. And then one of the things that most confuses everybody is like, okay, I got persistent volume. Everybody understands that concept, and it's like, what's a claim? Right? Like, so like it's a different way of thinking about it. It's like claim. I try to explain it to as like it's a way of scheduling, right? You're kind of like saying beforehand, before you provision the volume, I want X amount of volume and I want to claim it. Can you provide this for me, right? Whereas the volume is the actual physical thing. And then like, it's just a very different way to think about it, because if you don't run within Kubernetes, you just have, bare metals, like when do you ever think about this, right? You just, mount maybe like a volume on disk and then you're done. So, and then on top of that, you also have like things like storage classes, and everybody's like super confused. What is a storage class? Why do we have this on top of like persistent volumes and claims? Yeah, so it's like, there's that complexity. Oh, I think this one's funny because I run into this very, very often, not very often, but I've seen this enough where I like remember it, where like, oh, my pod is running, but my container like timed out trying to attach to a persistent volume. Like, what's going on? And then like the developers are like, oh, my thing isn't running, and why is this happening? And then like on-prem, maybe like you can go and debug what's actually wrong with like the layer below, like what's working, what's happening in the hardware level. Like maybe your network mounted volumes are not working. Maybe iSCSI is not running correctly. Like something is happening, right? And then it's kind of funny when this happens also on the cloud, and you're just like, wait, I thought this was supposed to be dealt with, and then you still run into this, and you're trying to debug it, and I'm like, oh, okay. So it's kind of funny because that problem just it's like I use this as an example, quintessential example of how, like, okay, you have this abstraction of Kubernetes, but you're still also bounded by all the hardware limitations as well as features underneath. And so you kind of need to know both layers. I guess, yeah, some of the other things like, mounting paths correctly in the container, accessing it correctly, like, that can be a little bit hard. Just also like, some people, I've had experiences where, developers just get confused reading the docs and just like figuring out how to do the mount paths correctly. And that's completely fine, right? Like, I mean, none of this is very clear cut. And it's like, that's the challenge of the Kubernetes layer with respect to storage. And only then we get to actually the application layer. I put level infinity because, like, to get to this, we already have so many layers below it to think about. Like at the application layer with respect to storage, you're like thinking about like, what's my backup model? Like, oh, it's funny whenever somebody says, I don't actually know how much storage my application needs. And this is actually not a weird question. It's sometimes just, you don't really know upfront, like how much you're going to write or how much storage you're going to need upfront. Like, you don't know at the end of the day, maybe you might need like, 3 times more replicas than you need it, or spread across different regions. Like, you might just not know, right? Like, especially if you're just rolling an application out like as an alpha. And there's, the types of questions you ask at an application level and not even thinking of all the layers below is like completely different world of things. I think I touched, rewrite patterns, very bursty stuff. So yeah, I mean, this one is a very good example just because your application, I've had to deal with applications where, they have like 15 minutes window of like very high write, and then like just it drops off a cliff, and then it just has this kind of like this seesaw kind of pattern, right? And then that kind of also goes back all the way back to the storage layer, the hardware layer I talked about before, where like, oh, this is one of the cases where I had to debug, like, why are we getting throttled? Oh, like on our vendors throttling our peak in reads and writes, and that's actually what's affecting the application all the way at the top. So like all these layers all work together. So yeah, anyway, so these, if you think about storage, like there are just so many layers involved with it and so many different perspectives to think about. And when you're kind of just, I almost feel like when you're kind of just dealing with all these problems, it's really easy to forget about, like, this is always actually how we forgot about costs and how much our operation costs is going to cost us, because there's just so much complexity, so many layers involved with it. And like, it's easy to not think about costs up front, like how many terabytes you're actually buying, how many terabytes you're actually using, when you're just kind of wrapped up in all this complexity. So yeah, storage is pretty complicated. But yeah, we're not done yet. How much does it cost us? And I want to kind of touch into, cost is not just like a dollar value thing, right? I mean, that is obviously the most important operationally speaking. And I mean, we're all running businesses. We all care about the spread, the balance sheet at the end. So dollar value definitely matters. But like, as an engineer, I'm also looking at it like, well, the cost can be also time, right? So like, it's not just like the dollar value, but like, how much time did it actually cost us, engineering time, to fix a certain problem? Or like, when let's say if we're migrating data from one stateful set with a bunch of PVC definitions to another one, like, did that cost us extra time? Could we have saved that by just like having a larger bucket, a lot larger PVC from the get-go? Like, I don't know. Like, you have to kind of make this, you have to think about it that way when making engineering decisions, right? Like, so I just want to point it out there because it's not just a dollar value thing. There's also a time aspect. And at the end of the day, it's kind of funny because like, we would think like, oh, we saved like, like all these thousands of dollars, great. But like all of us slaved like, 3 weeks, we're working like 60, 80-hour weeks. And then like, what did it actually save us? I'm not really sure actually anymore, right? So yeah, just to keep that in mind. Anyway, so this is where I want to get into some of the war stories and hopefully yeah, hopefully things that people can take away and find useful. So the first one is about how, actually what I just talked about, which is we were proactively trying to cut down costs, but it actually turned out to be very expensive. So we, as I mentioned kind of at the beginning, we run Elasticsearch. We run many of them across like all of our cloud deployments. Oh, and then just as a note to anybody listening, from now on, I'm kind of talk more about the cloud environment, just because that's kind of what I most work with. So rather than on-prem. So we're running, like, we do run a lot of different clusters. We do use GKE right now, and we just have it pretty much like many different clusters. Each of them are running these Elasticsearch clusters within them. And at the beginning, it was about like half a year ago, our Elasticsearch clusters weren't that used as much. We only had like maybe one custom application on the top that's just writing to Elasticsearch, and it was like, okay, we don't really need that big of a cluster. So we had downsized it to just like 10 data nodes. Each of them maybe only had like 100 gigs attached to them, PVCs. And that was because we downscaled it actually from like running like 20 different data nodes or even more, just because like we're like, okay, we're not using it much, and we're literally paying for the nodes that aren't being used as much, and the volume, the PVC sizes that we're not using much. So we downscaled all of it. And I just want to say this is like pre-operator era. We eventually migrated to using the Elasticsearch operator, which is like awesome. But it did take us some time to migrate, downsize our Elasticsearch clusters, just because like we were deploying using stateful sets. And I know this problem was fixed in later Kubernetes clusters, but like at the time, our stateful sets, you can't change the PVC. It's an immutable field when you deploy it. So like, because we had to change the PVC definition, like we had to redeploy everything, do a whole shard migration like manually, and then like this is like all of our clusters. It was a huge migration just to downscale. But we were like, okay, it's gonna be worth it, because we're gonna save at the end of the day like 10 to 20 different nodes per cluster, and for every cluster we've got, and we just went down from like a terabyte to like 100 gigs. So like, yeah, this is gonna be huge huge savings. And then it was funny because just 6 months after that, we had like a bunch of new projects are all writing to Elasticsearch, and we needed like at least 10 terabyte per node. And we were like, oh great, we just scaled it down. We have to do it all over again. And then this is actually where I was like, okay, I'm not doing this again by hand, because migrating shards is such a boring and extremely time-consuming effort operation. And I need to do this for all the N different clusters we got. So this is actually where we moved our Elasticsearch to be managed by operator, the official ECK operator at this point. But we ended up doing it again. So I mean, at this time we use operator, and the operator does an amazing job of migrating shards around. Like, I mean, it's a very dumb operation, but very repetitive, detail-oriented, operation. And so we migrated the Elasticsearch, the clusters back up again to and then we're just like, okay, what do we save? I'm not really sure, because like I think we saved about 6 months of dollar costs, but at the end of the day, the time we spent just moving things around, like I'm not even sure if that was really worth it. So this is kind of like classic case of like we were being really proactive to cut costs on our clusters, especially on one of our layers that we're running. But at the end of the day, it kind of turned out to be very expensive because of engineering time. And I guess some takeaway from this is like, I mean, it's really hard to predict what your business needs will be, obviously. You don't really even know what's going to happen 6 months down the road. But I mean, this is why I think things like operators are so important, because they are like I said, like, we cut down dollar costs, but there was a huge engineering cost just to move things around again. But, operators can really cut down on the engineering costs at the end of the day, right? So you might actually have a net gain in terms of costs that way. But if you don't use operators, then you might just be honestly paying for the same thing. So yeah, that was one of the cases. This one, So we run Hadoop clusters. Again, just like on all of our clusters, it's part of our stack. And it's an example where I want to share, like, I think it's really easy to fall into this trap where you have like a certain deployment, maybe a stateful set or just a deployment, and you have like the YAML file, and then like maybe you just didn't like tailor it to each different cluster's traffic needs or usage needs. So like everybody deploys, the same definition on all the clusters. And we ended up having situations where like on some of our clusters, our Hadoop clusters, or like the storages were were being used like somewhere even like 70 to 80% of the data nodes were full 70 to 80%, and we're like, okay, we got to scale now. And then we had some other clusters where it was just like, we're barely using like 10% of what we actually pay for this Hadoop cluster. And then, so that was all happening because like you said, we were being lazy, right? We were being lazy with the deployments. And I mean, it's lazy, and also we didn't really know, right? So we were lazy in the fact that we use the same deployments, but we didn't really know actually uphand like what all the different traffic would look like on different clusters. So it ended up being very expensive on the clusters without a whole lot of traffic, because they're just like paying upfront for all this persistent storage that we're not actually using. And it's always a recurrent cost. And, from like a vendor's perspective, or even on-prem, like nobody cares if you're actually using the storage, you're still using it anyway because you claimed it. So in that, I guess it's definitely a day two operation to go and optimize like, all these deployments based on your traffic and usage on each of the cluster. But it's something that you should definitely do because, it does cost quite a bit at the end. And what we ended up doing obviously was just, it's still manual tweaking. I think there's a lot of automation we can add to this, but we just ended up having like, we have the YAML files, and we just have, different persistent volume sizes configured, as well as also CPM memory configured for different clusters. And we just have to go and do that kind of like iterative operation just to make sure we're not wasting a whole lot of resources we're not using. And
so is that something that you're doing?
Yeah.
Sorry, is that something that you're doing by hand, like monthly, or how does that work?
Right now, it is actually manual, and it's something that I haven't done any of the work yet, but we're thinking about building like a Hadoop operator, just because we don't want to be doing, data node decommissioning by hand every single time, and then we're just like watching it, like babysitting this thing happening, right? So right now for us, it is manual.
How often?
But like a monthly check-in is correct what you said. Yeah, about every monthly. And right now we're still also in the process of having all the monitoring in for certain bursts of costs. And I did mention we're using GK, and they do provide very, very good APIs for getting like what is your monthly cost for different types of resources you're using. And then we just look at the storage. What is the trend in usage? Did it go up or down? Like, where is it most coming from? And I'm actually the one building that monitoring right now, so that we make sure we can predict in advance, and we are not like caught off guard at the end of the year, like, oh my God, our balance sheet looks crazy, But yeah, it is right now a manual process for us. I think there's tools like, I was also looking into a tool called KubeCost, because I think KubeCost tool does this kind of like cost breakdown for you really, really well. I think I haven't used it personally, but I think it's something that definitely should be used by other people too. But yeah, so kind of on the other side of this, I was mentioning like, we had this like deployment. It was all, it was the same, it had the same persistent volume configuration everywhere deployed. And, on the other side of this is, we did that also, and I think I mentioned this too, we did this also because we didn't know how to scale, right? As in like, not in that sense, but like different applications need different types of storage scaling, right? So for some applications, you definitely want to scale vertically. So you might have just one persistent volume and scale vertically, because your application might perform better on a monolithic block of storage, right? So you might have that situation. Applications like Hadoop or even Elasticsearch, they are great in the fact that you just can tack on more data nodes, horizontally scale, and you can scale it very easily like that. So, knowing how your application's data is going to scale actually is very helpful, so that you don't have to over provision so much upfront, right? So if you know that, for example, like we knew for Hadoop, we're just going to add more data nodes, and we just add as X many data nodes as our replication is set to. So like if our replication is set to 3, then we just add increments of 3 and we're done. So like we knew this, so we really had no excuse of like, over provisioning each of the data nodes with like 100 terabytes, which is kind of like what we did, which is why it ended up being a lot of cost. You don't need to do that, because you can just horizontally scale. Why pay for so much storage and nodes and CPU memory and all that up front? So it's just something to think about, because it really does help you for over provisioning everything up front if you know like how you're gonna in the future scale up, right? I guess this kind of bleeds into what I just said, is like I've definitely ran into situations where we had some custom applications. We had developers building them, and they're trying to like just run on our cluster, and they're like, I don't really know how much my application needs, so I'm just gonna get like a bunch of these terabytes everywhere, and then like they're not even using it. For that, I mean, this is actually where we do have monitoring for this. So we monitor how much each PVC that we have, how much is actually written and used. It's just a file system calculation within that PV, how much is being used. And we just, flag the ones that are being used less than like 20%. We go and like chase out the developers, like, hey, do you actually need this much storage? Can we cut this down? Like, what's going on here? And like, as an SRE, it's always like a fun conversation with a developer of trying to get them to understand like what is their actual data usage needs, and like how much do they actually need? And they might not know at front, and it's kind of an interesting interaction there. But yeah, lazy and expensive when you just like ask for a whole lot of storage and you don't even know how much you need. This is an interesting one. So like, this actually goes back to Elasticsearch again. And this one's not as clear cut, because it's like a design decision of, we had Elasticsearch, some indices that they had like a primary shard, 2 secondary shards, and each of them had like replicas. So we ended up having like 9 shards per index, which is great. Like in a daily basis is fine. But this thing also had like a rollover index policy of like of every day, of every historical index copy that it had made already. So like, it's like an exponential growth of shards. And then this was it was interesting because the developers that had this index rollover policy didn't really predict uphand. I'm not really sure why, but they didn't. They were like, oh, we wanted to be just like extra safe. We have like extra backups and extra replicas, and like we don't have to worry about maybe losing data later on. So it ended up literally being like just a pile of demonic looking shards that we had like thousands and thousands of shards just for this index, and we were paying for it. And on top of everything, we were running our Elasticsearch cluster on a node pool that was autoscaling. So it just happily went and added more nodes, and like it just kind of grew with the size of the number of shards. So it kind of like quickly got out of hand. Like within a month, it was like it was just exponential growth, number of data nodes, as well as the number of nodes we were data nodes that we were buying, as well as the storage per data node we were paying for. And then we were alarmed just because at the end of the month we were looking at our balance sheet. It's like, where did this huge jump of storage costs came from, as well as CPU and memory, right? And it's like, oh, it's like this rogue index that just needed way too many replicas, and it didn't even need it. So we ended up, day 2, I guess this is like not even day 2, it's like day N operation. We went back and we just reviewed it, and we're just like, hey, do you really need this? Like, do you really need to make a copy of all the historical copies of what you just made? Like, for the entire, and only after a month it would actually, garbage collect itself. So it was huge. It was huge waste, and I mean, this you can't really catch upfront and really really good review process. And I don't really blame the developers here either, but it was really like a heart attack of a cost increase, and it was like across all of our clusters. So yeah, this is, design
So
decisions.
the way that you went about fixing that was just going through and figuring out if it was actually needed from
We cut
the
down, so
developers?
the index, we cut down on the replicas. So like the primary shard would still have 3 replicas. That's fine. But the secondary shards cut down all the replicas. So we cut down on the number of shards being created in the first place. And then we also said, and the developers are like, okay, we actually don't need to keep around this many rollover indices. So we just cut down that as well. So it only rolls over only after a week now, and we don't keep beyond after a week either. So it was just a huge review of cutting down data we don't need, and it was just like something we should have been done. That's something that should have been done like way earlier in the process. But you learn the lesson at the end of the day.
Yeah, and it's one of those things, like you said, you don't see it until a month later, and you go, oh, so that happened. Oops.
Yeah, and then I get it from a developer's perspective. I kind of get it, because like your biggest nightmare is losing data, right? And not having a backup to roll back to, or not having the frequent enough timestamps in the past data that you can just use and collect. Or sometimes even like if you have an outage or if you have a bug, you have to grab data from like way back when, and then prove that like it wasn't ours, or like it wasn't our algorithm, or maybe it was something else that happened. So I get it from the developer's perspective, but it's like you got to balance that with also the cost you're willing to pay maintaining all of this infrastructure, right? Yeah.
Totally.
So, I love this one because it's insidious and it's really hard to catch unless you have the monitoring for it. So, crash spoofing deployments. So when you have pods that are asking and have already provisioned for like some n number of persistent, persistent volume claim, and it already had the volume provision for it, but it's just like it runs, attaches to the volume, crashes, attaches, releases the volume, crashes, and it just does this loop over and over and over and over again. And it's not doing any useful work, right? Because it's just crashing, doing nothing. But we're still paying for the storage and also the CPU memory and the node that's required to schedule this thing. The only way to prevent this is really monitoring, and monitoring for workloads that are really not doing anything useful, but is still taking up resources in the cluster. And I find this especially insidious for on-prem, where you can't as easily scale out quickly in resources, right? So on the cloud or on a public cloud vendor, like, getting like the next, 100 nodes or whatever, it's like, it's just a button click or, a deployment change. It's not that hard. But obviously on-prem, you can't do that. So it starves the resource that other applications could have used with your bad deployment, not just going there and flopping all over the place. So yeah, that's why I consider this a hidden cost. Things you just don't think about until you find it. The last thing I have is, I guess it kind of goes back to the Elasticsearch example too, but being extra protective, and that kind of can also create some hidden costs. So we had this situation on our cloud clusters where, so we have multiple clusters, and some of the clusters are used for just development and or testing. And that's separate from our prod clusters, our pre-prod clusters, and what have you, right? And the dev and testing clusters are the ones we expect to be the least cost to run, because they're usually the smallest, as well as we try to scale it down as much as possible so that we can spin it up quickly, and they're small and agile, and a lot of people can use it, but we don't have to pay so much for it. But it was weird because we were like doing, our monthly, just like looking at, balance sheets, and we're just like, why are dev and testing clusters showing the highest cost? Like, what's going on here? And we later realized we're using storage classes where all the reclaim policies set to retain. So like, great. So every time somebody's deploying something and they undeployed it, it looks, the persistent volume claim is gone. So it looks like they cleaned up everything, but the persistent volume is still there because of the reclaim policy which is set to retain. So basically, if you had like 100 different people, developers, like deploying their own thing, oh, and they still cleaned up. From their perspective, they cleaned up because they deleted the deployment, deleted the persistent claim, volume claim. They didn't realize the persistent volume is still there. So we had like hundreds and hundreds of all these like just like random persistent volume just like sitting there, released, unused, just sitting around. We're just like, oh, well, great, yeah. So like, so I mean, but we do want the reclaim policy to be retained in case we have to like do an emergency fix, like, you know, manually create persistent volume, reattach it to an application, just like have it run. And I've done this for a Hadoop data node before. It was like just to make it, we were, you know, it's on one of our clusters having an issue and we just have to recover that way. But it is not wrong, but on the test and depth clusters, we just didn't really need this much protection for data. So we cleaned up the release persistent volumes, but our recurring costs still didn't change, and we were like super confused. Like we were like, oh, I thought we cleaned it all up. And then what happened? This is only relevant for cloud, but we were still paying for the underlying disks, the virtual disks that we had bought. So like they were still sticking around. It's something that we didn't clean up. And after we cleaned up those persistent disks, finally the costs were gone. And it took us like, I think, a good month and a half of iteration and looking at like, what is going on? Where's our cost coming from? To figure out, you know, like we were wasting a whole lot of costs here and there. But yeah, being extra protective, you know, having these multiple layers of honestly protection for your data loss, like great, but it might also bite you in the process, especially for, you know, clusters you don't need that much protection. But yeah, so that's a hidden cost. I guess to kind of like wrap up, I know I touched on a lot of different things, you know, a lot of different perspectives on Kubernetes. Yeah. I unfortunately don't have like best answer for like how do you manage your costs most effectively. I mean, I think it really, it's a very iterative process. Like monitoring. You need to have monitoring there to understand what's going on, have visibility, observability into your cluster. You know, everything from crashing pods to, you know, how much volume is being bought, how much volume is actually being used, that was bought. But you got to also balance priorities. Like that goes back to the Elasticsearch index, you know, design issue that I brought up. Like, what is your priority, right? Like, are you focusing on backups? Are you focusing on high availability? Are you focusing on having as many replicas as much as possible? And also just like, what's your priority in terms of like, are you trying to reduce as much dollar value dollar cost as much as possible? What about engineering time? Do you balance both, or are you gonna just only focus on one or the other? But I think at the start, so when we first started kind of deploying all these clusters and managing all of them, it was definitely, we're just trying to get the dollar values down, right? Because it's just like the engineering time is at this point just a sunk cost. We have to do it. But like once you kind of do like day 1, day 2 operations, day n operations, you have the kind of luxury to think about like, okay, how do we cut down engineering time, which is also a cost. But yeah, I think, yeah, balancing priorities. It's always going to be iterative. I think that's it, actually. I think I took up the full time.
That is, yeah, that is so awesome. I really appreciate you talking to us about all of this. I mean, I've learned a ton, and it's very helpful. Hearing war stories is always interesting and sometimes a little bit painful, but
yeah,
it's great to learn from others that way so that we don't have to do it ourselves, hopefully. Some of us takes a little longer to learn, so I know that we don't always follow the recommendations, but I really want to thank everybody that's with us. I want to thank everybody that's listened, and I want to give you a big thank you, Ren. This has been awesome. I'm going to wrap it up. If anyone has any questions, feel free to reach out to myself or Ren in the Slack, or best way to reach you. I see you're also on LinkedIn. We are connected already. If anybody wants to connect with Ren, feel free to. And yeah, I'll see you all next week, same place, same time, for more data.
Thanks for listening and having me here today.
Yeah, it was awesome. Thank you, Ren.
Goodbye, everybody.
See you, everyone.